Hi friends, it's Kamal and you are watching Maths by Jajoria. Please don't forget to subscribe my channel. In this video, there is a continuation of my last video where I have discussed the gradient of the gradient of the line joining the points with the coordinates. So I have discussed that as well, and to find the gradients also, and it was also about the intersection of the lines. So now this is the continuation of that. So those who haven't seen my last video, I will recommend you to go and watch that first before move on to this video. However, I will have the link in my description box, those who haven't seen that. So let's start with this one. In this video, we will talk about the parallel and perpendicular lines with gradients. Okay, and the first step here we'll go through is the parallel lines. So if you have a parallel lines, which I have here, one representing with the different color and one with the red. Parallel lines have the same gradient. Okay, so these are the rules. This is what we will discuss. I'm just gonna go through one of the example with that. So let's say a line is parallel to the line. So where it says one line which is unknown, and there's parallel to the another line which is that's the equation for that. Okay, and it passes through the point. So the point has been given to you. So that's the point, and that's your line. And what it says, that work out the equation of the other line. So in other words, that one line equation is given to you, you may need to find another line. Okay, now remember that parallel lines have the same gradient. Okay, so that's the catch. Okay, right, so let's work with that one. The first write down here. So equation is 6x plus 3y minus 2 equal to 0. Okay, now as I have explained previously, that we have to rearrange the equation with the form. So I write down here as well. And again, I recommend you, if you haven't watched my previous video, please do so. So arrange this equation. Okay, with the form. Okay, so what's the form is y equal to mx plus c. Okay, and where m is gradient. Okay, so this is what we have discussed previously. So what it says is to find m. Okay, so m is a gradient. Now let's rearrange this. So simply write down 3y equal to, that's 6x and minus 2 goes other side, minus 6x plus 2. Okay, and what the y would be? Minus 6 over 3x plus 2 over 3. Okay, so that would be, so because we need to bring this into this form. Okay, that's why we have to rearrange this. So what we call y equal to minus 2x. Okay, and plus 2 by 3. Okay, 2 over 3. Now what we have to do this now, so you have got this in this form, okay. What we do now is compare this form with the y equal to mxc. So when you compare this, so I would say compare this with this form, and you see, so I would just write down here so that you know. So compare these both lines. Okay, so what you get here, so when you do this, we get m, which is a gradient, is equal to 2 minus 2, sorry. So that's your gradient. Okay, so -2 when you compare that, because m is here gradient. So you got to -2. Now, as you know, the gradient of the line is -2. Parallel lines have the same gradient. Okay, from here, parallel lines have the same gradient. Okay, so now I think you got it, what I'm trying to say here. So therefore, the other line which we need to find, that will have the same gradient. Okay, so however, I write down here for you. So let's write down here. So gradient of the line is -2. Okay, so write down here. Let's write down here. Gradient of the line is -2. Okay. Now parallel lines have the same gradient. So the gradient of the required line. So this is what they're saying. Is work out the equation of the line. Okay. So what that would be? It will be -2 as well. Okay. You got it? So let me write down here, because these are the parallel one. So we write down here. So the gradient of the required line, the gradient of the required line is also to -2. Okay, from here. Okay, and you know it says here that it passes through. It says that a line is parallel to this line, and it passes through this point, this coordinate. Okay, so this is what we have here. So you know that this is x and this is y. So we write down this here. So you got 0 and 3 is the, what is that? Intercept on the y-axis. Okay, so this is what I have discussed previously. So I have explained everything in my last video. So you got here, this coordinate, this point is the intercept on the y-axis. Okay, y-axis. So what that would be from this line, C, what you see would be, C would be 3. Okay, so C is 3. So now you know you have got your M and you got your C. So all you need to do is just fit into this form. So equation for the required line, which is the parallel to this, that would be y equal to m is your -2, x plus c is 3, and that would be your answer. Okay, so whenever someone asks you in your exam or anywhere that one parallel line is given, then you know how you can find the other line equation. Okay, right. Now a lot to do today, so let's move on to the next bit. Just one of the rules as well. The equation of the line with gradient m that passes through the point with the coordinate x1 and y1 can be written as, so this is just a form we can write, because we will discuss this further. So how we can write down, so before I move on to that, how it can be written, let's move on to this side first. So here you see this point on this line, which is represent x1 and y1. Okay, this point here is known to you, so the point on the line you know. Okay, so this point you know. So let's say someone give you the example that this point is known, but this is any point, so which is x and y. Okay, any point means that you don't know. Okay, so when you have this thing, it says here, equation of the line with the gradient m that passes through the point with the coordinate. So that's coordinate is being, so coordinate has been given to you, can be written as y. So because you are here xy, so it will be y minus y1 equal to m is a gradient, x minus x1. Okay, right? So in this way, you can see here that this is any point, and this distance here from here on the x-axis from here to here, this distance you can have always from x minus x1. Okay, so that to find, so this is your x here, and that is your x1 here. So it's always minusing from x to x1. So that distance would be, in case you need to find that distance. So that's what the equation here will explain to you. Same thing here. This distance here from here to here is on the y-axis. Therefore, you have here this point here. If I just suspend this side here is y1, and in here is your y. So what that would be, y minus y from this one, because it's a higher point, y minus y1, which is your y1 here. So then you know that distance you can find from here if once the coordinates is given to you, or you need to find the coordinates. And because of this explanation, I would say that that explanation is for your this equation. Okay, so I just write down this one again here. That one is y minus y1 is equal to m x minus x1. Correct? Okay, so this is what it is. There, what if you want, we can move on to the another rule, okay, which is very important as well. You don't need to really worry about here the equation of the line, because we will cover this as we go through these examples. Okay, now one thing with this gradient, parallel lines, and the perpendiculars, I would like to say to you that very important part here, which you need to know, that perpendicular lines. So now we were talking about the perpendicular line. Okay, so here is the example of the perpendicular lines. Okay, so these are the two lines here. Okay, so please concentrate on this part because it's very important to understand. Okay, so the perpendicular lines at the right angle to each other. So this perpendicular line right angle to each other. Okay, if you know the gradient of one line, okay, so any of the line, I would say, if you know the gradient of the one line, you can find the gradient of the other. Okay, so I will always explain to you with the example the how we can do it, but you need to just understand how it works. Okay, now here the second rule here is that if a line has a gradient of m, so let's say if one line has a gradient of m, a line perpendicular to it has the gradient of -1 over m. Okay, so that's what you need to know. So let's go with the example here. So you see here shaded triangles here. So shaded triangles here, one triangle is here and the another is here. On the one is the L1 line, this one, and so that's L1 line, and this is your L2 line. Okay, and the shaded one triangles are here, are congruent. So in GCSE you have studied about the congruent triangles. Okay, so I won't really go too much on that one, but just to say that the sides and the angles, most of the time you find that it's the same. So that when you have the congruent triangles, then you need to also see the different types of properties in the congruent triangles. Okay, so let's now not go into that because that's you probably covered in your GCSEs. However, because we have to concentrate on the gradient here, how that will effect on your gradient. So let's say the line L1 here, I would say when you have here A and B here, as you see, so the A over B is equal to the M. So that's gradient of the L1. Okay, so the line L1 has the gradient M. Okay, now L2 here. Okay, again I would say to you that you need to just go through a little bit on the triangles properties, or when the triangles are congruent. Okay, so the L2 has a gradient minus B, okay, over A here, okay, and that will give you minus 1 over M. Okay, so now again with this, move on here where it says if a line has a gradient of M, a line perpendicular to it has a gradient of minus 1 over M. Okay, remember that please. Right, so that's, once you remember that, it will help you in the other examples when we will discuss. Right, another one also before I move on to the examples. It says if two lines are perpendicular, which like this, okay, the product of their gradients is minus 1. Okay, so remember that as well. So it's pretty simple how we got that with that one. So if it says, let's say your L1 is M, and then you got here L2, which is minus 1 by M. So it says product, which means what? Multiplication. So in other words, when you have the gradient and the product of that, multiply that one, so cancel that out, is minus 1. So that's how they got minus 1, just in case you're wondering why it's minus 1. So this is from where we got minus 1. Okay, right, hope it's clear. So these two and one here as well, the equation of the line. So these are all very important, so let's move on with examples. Okay, now I will keep this one here before moving to the next example. Okay, all right, so the next example here, let's get this first. Right, so the next, it says here, maybe I think I can, should I use the next page, or can I do it here? Maybe I can do this here. Okay, so the one example here, it says we need to work out whether these lines of the equations which we will write are parallel or perpendicular. Okay, so this is what they will ask you in the exam. They will give you equations, and they will say, okay, without even just find out, they will say whether these lines are parallel or perpendicular. So how would you do that? So the question will be something like this. Whether these pairs of lines, pairs of lines are parallel, yeah, or okay, they can say parallel or perpendicular. Okay, or neither. They can say or neither. So they can also ask you neither. Yeah. Okay. Now, when I will go through explaining you some of the questions, I may write parallel like this, okay, and perpendicular like this. So just in case, you can just save us time. So parallel like this, two lines, and perpendicular like this. I will try not to use it, but then if I use, you know what I'm talking about here. Okay, so let's go here, and this is your 3x y minus 2 equal to 0. Okay, and then you also got x plus 3y minus 6 equal to 0. Okay, so they're saying find out whether these are okay, parallel, not parallel, perpendicular, whatever it is. So first step here is to do, you rearrange that. So rearrange the equation into the form which is we discuss here. First form, y equal to mx plus c. Okay, so that's form most of the time you will see that we need to rearrange that. So rearrange the equations, okay, into the form y equal to mx plus c. Okay, right, so let's do this first. bring this here. Okay, so bring this equation here first. Should I write down here? Okay, let's write down here then. Okay, so that would be your 3x minus 2 equal to y, because you have to write in this form. Okay, so what your y would be? So your y would be equal to 3x minus 2. Okay, now as you know, when you have this form, what is your gradient? So m is your gradient. Okay, so you know what I'm gonna write here now next. So write down here the gradient of this line. Okay, so which is this line. Okay, so I can write this line is 3. Okay, so the gradient of this line is 3. So you got one line gradient, so this line gradient. Now you know what I'm going to ask you now. Okay, so do the another one as well. Okay, so let's write down this here, the another line, which is x plus 3y minus 6 equal to 0. So I haven't got much space here, so I'm just gonna go and turn this page. Okay, so they make it clear. You don't want to just write over other things. So what we got here? We got here x plus 3y minus 6 equal to 0. Okay, so that is another equation. Yeah, x plus 3y minus 6 equal to 0. Okay, so let me just go through the previous one, which equation we had. Okay, just give me a moment, please. Okay, so the one we have this equation here. So 3x minus 2 equal to y. So with this we got 3. Okay, and then we got here, yeah, so it was correct. Okay, only thing here is this equation here. So you got here, so let's cancel this out because our equations were x plus 3y. No, that's correct. Okay, so this was our second equation. Okay, sorry about this for time consuming. Okay, just wanted to make sure that taking the right equations other side. Okay, so x plus 3y. Yeah, so it's the exact one. Okay, I don't want you to make a mistake on the, taking the both same time, same equation, and then would have the different gradient. So we have this another line here, which is x plus 3y minus 6. So with that, you know what I'm saying. So bring in this form. So y equal to mx plus c. So you got here 3y equal to what you got here minus x. So we keep this here, take the rest of things other side. Okay, plus 6. Okay, and then y, your y would be, okay, so this is your y. Okay, so minus x over 3 plus, so this you can solve this as well, condense that as well. So your y would be equal to, I can write like this. Okay, make easier, cancel this out, that will give you 2. Okay, because we need to know gradient, right? So you know now that this equation, this is your second equation. Okay, I think I should write down like this. So this is your first equation and that is your second equation. Okay, much easier for you to just go through that one. Okay, so first equation, right? So first equation and the second equation. So now with this equation, second equation, this is your gradient, minus 1 over 3. Okay, so you know now you got two equations. One is 3 and another is 1 minus 1 or 3. So now what we have discussed previously here. Okay, so it says here, if the lines has a gradient of m, a line perpendicular to it has a gradient of minus 1 over m, Okay, if you when you have that, then it says the two lines are perpendicular. So when the lines are perpendicular, when the product of their gradients is -1. So this is something we will get here. From here, we have seen this here. The gradient of the line is 3. Okay, right? So what I do, I write down here. So the lines are perpendicular. Okay, as you do 3 was the gradient from the previous line. Okay, first line, this gradient is -1/3, and that gives you what? -1. So when the lines are perpendicular, when their product is, two lines are perpendicular when the product of their gradients is -1. Okay, so this is what you got, right? Okay, so now we can do another example with the same one. Okay, hopefully this time will be, let's say, may not be perpendicular. Okay, we have a space here, we can go through now. So one question is y equal to half x, another one is 2x minus y plus 4 equal to 0. And I think this time I will label 1 and label and equation 2, because in the last one I was just got some confused that whether I'm working on the same line, and obviously you don't want to do that in your exam. Okay, so again, same thing here. So what we do, we compare y equal to, so this is the equation first we take. Okay, same thing as the last time with y equal to mx plus c. Okay, so you know here, so your m is equal to half. Okay, the gradient is half. Okay, so for this line here, so for line, let's make easier, so let's say line 1. Okay, and better to write as well x here. Okay, so the gradient of this line is half, right? Okay, then we bring in the second line. Okay, so the second line is 2x minus y plus 4 equal to 0. Okay, same thing, rearrange that in your which form? Y equal to mx plus c. Okay, so let's rearrange this one. What we will get here, so take your y other side here, so that will give us y equal to, you left with what here, 2x plus 4. Okay, just take minus y other side, that's positive, y equal to 2x plus 4. Okay, so in that one, what is your m here then? So this is your m. Okay, so because you got in this gradient of the line, so just write down here. Okay, just to make sure that you write for the each line gradient of this line. Now line second. Okay, so second line of this line is 2. Okay, so once you got that, one is 2 and one is here, gradient is half. Okay, so let's write down here, because you have to explain here everything. So now what you do, compare y equal to 2x plus 4. Okay, this with y equal to mx plus c, and it says so m is equal to, so please do write this, okay? So just don't just write gradient of the line is half and then second one is gradient of the line is 2, and then you're not explaining, because you need to explain that, because they're asking you, whether these lines are parallel, perpendicular, or neither. So, you need to have some kind of justification in there. Why do you think that? Okay, you can quote that as well. That will be, I will really recommend that as well in exam. Okay, uh, if you can remember that one. Okay, just going with this one, exactly the same. You can quote that as well here. If depending on that, if they're perpendicular or not perpendicular, so you can quote these lines as well here. Okay, right. Okay, so let's do this one. So where were we? Okay, so we were here. Yeah. Okay, so it says compare y equal to this, which is just as this line second here with this, and then you write down here this form, and then you're saying that your m is equal to 2. So now you know that if you multiply this one, uh, m and this gradient, you won't get -1. Okay, so you know this thing. So in that case, what happens? So I'm just going to write down here that when the lines are perpendicular, the product is -1. So if you see here is half multiplied 2, and that is not giving you -1. That is not -1. Okay. Okay. So I will write down this later on as well. However, just before I just write down here. So you will write then the lines are not okay. So the lines are not perpendicular. Okay, as their gradient. So lines are not perpendicular as half multiply. Okay, so that's gradient, and 2 not equal to -1. Okay, not equal to -1. All right. So now what else then it can be? Okay, because their product is not equal to -1. Okay, and just going here. Okay, what was saying here? Parallel lines have the same gradient. Are they parallel? So let's go and see. Same gradient? No. One has half, another 2. So what else you will write here? Then you will also write that the lines are not parallel. So neither of perpendicular parallel. Okay, please do write as well everything. Your justification is very important, as they have what different gradients. Okay, so you need to write that okay, the why do you think that they're not parallel, and also why do you think they are not perpendicular. So you have done that, as here you say as they have different gradients. Okay, so same gradient, that would have been the parallel lines. Right, that was a good one, good example. Now before I complete this video, I would like to go through another example as well. These kind of things can be asked you in the exams, which carries a good marks as well. Okay, and sometimes best to know like some good examples. Okay, so let's do this one. So what it says here, it says point. I have a space here, so I might start starting down from probably here. Okay, so it says point A and C lie on y-axis. So this is your y-axis. Okay, and it says point A and C. So this is your point A, and that's your C on y-axis. That's your y-axis. Okay, it says lies on the y-axis, and the point B, which is here, lies on x-axis, which is x-axis here. Okay, so that's as you can show in the diagram it says. So obviously you can see there that this is what I have done for you. And then you also got the coordinates here, 0 and 4. Here you go -3 and 0. And then again here the C1 is here 0 and the C. So I think you got it what they will ask, what the examiner will ask. So it says the line through points A and B. So line through points A and B, okay, so these points is perpendicular to the line through B and C, okay. So in other words, yeah, okay, rather than going into this, all you can see here, the two lines here, these lines, you got 3 points here, one line this, and this is perpendicular, okay. So it's all you're asking is the value, find the value of the C. So it's saying find the value of the C. The C here is here, okay. This is what it's asking, find the value of the C, okay. If you get this kind of question in exam, yeah, it will carry a good marks. So let's go through that one. Okay, so I'll start from here. Okay, so that you have your question here as well. Okay, I'm not sure if I use this part, would I be able to really, maybe I can do it. Okay, let's see if I can do. Right, so let's start with that one. So first what we will do, you will say the gradient of, so logically think about that, what do you actually really need to do. So the gradient of the line AB, so this is your AB, okay. So the points being given to you, 2 points are given to you, so you know that you can find your gradient. So let's write down your points first, okay. So let's say if you have points x1 y1, which we can say here is your 0 and 4, okay, and then you can say your x2 and y2 points, and that you can say here b, okay, and that is your -3 and 0. Got it? Now as you know that to find the gradient when the points on the line, gradient of the line when the points been given to you, that is what was the formula? Okay, so that is your m equal to y2 minus y1 and x2 minus x1. As against, I would say to you that those who haven't watched my last video, please do so, because I have explained this in details. So what that would be then, the gradient would be, so the m, that will be y2 minus y1. So what is your y2? Y2 you have 0, y1 is your 4, so that you will write here 0 minus 4 and then you have x2 minus x1. So x2 minus x1, that is your -3 and -4. So that is your -3 and minus, so what is your 0? Sorry, the 0 here, x1 is 0, so -0. Okay, so that will give you what? So you have -4 here and -3 here, so that will cancel out, and then you will have your gradient 4/3. Okay, so you got here this one 4/3 here. Okay, so the gradient is your here of AB, yeah. So write down here m is equal to, all right, so you got one gradient. So now again same thing, when the lines are perpendicular, okay, what the gradient of your B and C would be? I think you got it, what that would be. So let's write down here. So gradient, okay, which is perpendicular, okay, just sign the perpendicular, which is your line BC, okay, gradient is of the perpendicular line BC is what that would be, okay, as it says that is -1 by m, okay, remember. And then what is your m? M is your 4/3, so we just, it will be flip that, it will give you -3/4. Okay, so if you just substitute the value of m here, 4/3 here, and then you will get -3/4, okay, by solving this, right? I'm sure you can do that. So now that is your So the gradient of the perpendicular line BC, is minus 3 by 4. So the gradient of the line, that is your gradient of the line. Okay, right? So you can write down here that so then the gradient of line BC, okay, is this. Okay, right. Now once you do this one, now you know the gradient of the both lines. Okay, so now there is a catch. How would you get what been asked, which is C? Okay, so here we can say, right, we can say y2 minus, again the same thing for that one, y2 minus y1 over x2 minus x1. It's the same thing as like for gradient. Okay, that is also equal to, okay, so this is what you need to do, equal to your C. From here you'll get minus 0, because you have found gradient here. Then you see gradient of AB, which you done. Then you said the gradient of the perpendicular line BC would be this. That is fine also as well. However, you will also say how would you get the gradient of BC when the points been given. Yes, points been given to you, minus 3, 0, and here 0 and C. So you understand what I'm trying to say? When we will compare that, when you will compare this, when you will write this C minus 0, and then you got 0 minus 3, exactly the same as what we done here for line AB. We're doing the same thing for the BC. You got it? Right? So once you do this one, okay, so you got here C, which is your y2, and y1 here is your what, 0. Okay, so you can say here, yeah, C here minus 0, y, this is your y1, then x2 is your here is 0, and then x1 here is your minus 3. Okay, solve this, what you will get? You got C and 3. Okay, that minus and minus, that will be plus. Okay, so now you know, as you know that m is equal to okay, this is what I'll just write down here. Okay, from there you got, so that is your C by 3. Okay, so now you see you have your C over 3, and you have here your gradient, because that is your m. Yes, what is your gradient? Okay, so for this line you got your gradient already, line BC, because once you got gradient with the help of AB, line AB, so once you got BC, then we have to work on this BC line. Okay, this line we have to work. Okay, so through AB we got gradient of BC, then we have to work with BC in order to get C, and this is what we're exactly doing. All right, so this is what we got here. You got here your gradient, which is here, and then with the help of this you got the coordinates here, and then you got your gradient, which is C by 3, which for this exactly, and then you're comparing that because you already know the gradient of BC. So that what you exactly did with the coordinates, you just say this is equal to this, therefore your C is equal to, so the cross multiplication you can do that, C is equal to minus 9 over 4. Okay, then you can say, okay, this is what it is. Okay, find the value of C. So that's the value of C. Okay, so this corresponds, you got this here. If you want, I can write down here. So it was cross multiplication of that will give you your 4C equal to minus 9. Okay, then you got C equal to minus 9 by 4, just in case you want to know. And then you got here C. So find the value of c. So the value of c is, there you go, minus 904. So that is your answer. Okay. Now, if you get something like this in exam, that will have a good marks, very good marks. So just make sure that you understand this. Have an understanding of this is quite important. As long as you follow the rules of the gradients, you can think how you can solve the problems. All right. So for today, more or less what it is. Okay. So do me a favor, if you're finding this video informative, please like and subscribe this video. And as I always say, that when you subscribe, it just motivates me to make more videos. And be sure to click like button and drop a comment if you have any questions. I will do my best to come back to you, reply back to you. Okay. Thank you.